Hi guys, I'm Tarun Chanagar. I'm the founder of Delta Codec Software Solutions. So today I'm so excited to share with you guys with, my research project. So this smart monitor measures soil moisture threshold value and temperature humidity values. So this is AgroLink smart handheld device. So this project I had inspiration to create this project when I visit Habutale Tea Factory, where I learned about some challenges that tea pluckers and farmers face to measure soil moisture to optimize their tea plucking schedules. So this problem they are facing motivated me to create this innovation and hand over it to them. Alright guys, as you can see, this is the interior of this device. So you can see some sensors I used to make this device. So this is the OLED display, and there you can see DHT11 and ESP32 device, and also soil sensor, soil moisture sensor. So here I use this lithium battery, which names 18650. So you know the name. This lithium battery to power up this ESP32 device, and also I use this buck converter to step down my voltage. Also use this TP 45, I guess, yeah, is the name, TP45 charging module to power up to charge this lithium battery when power goes down. So this is the interior of my device. Now let me introduce some special features in this device. So considering about developer easiness, I use this OTG cable inside the device, and it connects to ESP32 device, and get this female port outside of the device. And now you can connect this port right here like this, right here like this, and you can also have another male USB port to connect to your PC or laptop to upload any updates to this device. So this is a special feature. You can see male to male USB cable, and you can also charge the device in here. So that's it. This is the interior of my device. As you can see, there are some complicated process inside it. So yeah, now let's move on how our mobile application works with this device real time, and update how it update when our temperature, humidity, and soil moisture levels changes. And also I need to show some other features. So the device I designed integrates multiple sensors and display to provide real-time data. It features this, you can see, DHT11 sensor to measure temperature and humidity, and also this soil moisture sensor. You can measure current soil moisture threshold value using this. Also, you can see there are some LEDs to indicate dry soil, wet soil, and also high water level in the soil. And using this is finding our Wi-Fi connectivity. So this display, you can get real-time update data about temperature, humidity, and soil moisture. So that's it. And also you can see this LED to indicate Wi-Fi connectivity. So it blinks when your suitable Wi-Fi connectivity is lost or trying to connecting. And this LED, it shows your Wi-Fi disconnections, and your data is going to database to the server. This LED blinks 5 times, and that's it. This is my interior of the device. So let's move on to our next part, how mobile application works with this device. So previously I said TP45, but its correct name is TP4056 charge module. So this is how my device charges. So guys, now you can see my mobile interface, and in the left side you can see how I test soil with my device. So it changes current temperature, humidity, and soil moisture threshold value in my mobile interface. So you can see with my OLED display live update and mobile interface live update. So this is how we test soil moisture values, temperature and humidity with our mobile application. Mobile application is basically developed with React Native technology. That's a trending technology these days. So here you can see how it update live data with the device. So now you can see temperature is 27 Celsius and humidity shows 70%. And when I put my sensor into wet soil, it indicates this orange LED. You saw it. So guys, that's it. So that's how we can test soil with our device, and how it live updates our mobile interfaces. So I want to show you guys my device welcome interfaces. So this is my company logo, and here comes my project name, AgroLink, and these are developer credits. So I need to enter a very dark place to show this because OLED display is so shiny. So it's not you can't totally see it in daytime. So that's it. Wi-Fi connecting, and it blinks 5 times LED, and now my Wi-Fi is connected. So here it is, guys. Our device is working now. Here we go, guys. This is my circuit diagram for my device. So let's explain briefly what is it. So in the middle you can see ESP32 device, and the left side of it you can see a DHT11 sensor to measure temperature and humidity, and the right side you can see soil moisture sensor to measure the soil moisture threshold value. And you can see there are 6 LEDs to indicate our measurement levels, Wi-Fi connectivity, disconnections and data saving parts. And also you can see the above the ESP32 device, I connect my OLED display to ESP32, and now you can see I step down my ESP32 voltage. So I use buck converter to step down the voltage. So in ESP32 we can get 5 volt as input voltage, and we want to step down into 3.7 voltage to power up ESP32 with this lithium battery. So this is my circuit diagram for the AgroLink smart monitor device. So I'm pretty sure you can understand how is my circuit going with that device. So that's the brief explanation. You can see this is my backend part. So I do this backend part with Java 7 and these are the files I have to do. I have to code for this project. So this is basically data access object. So you can see sensor data DAO file, and this is my backend part here. And also I develop this data transfer object, sensor data DTO, and this connects directly with my MySQL database. And also a hibernate util file and sensor control file. I use this part to control my all data transferring and searching process in device. And that's it, guys. So let's move on to our Arduino code. So which code using C++ language. So this is my C++ code, which codes in Arduino IDE. So you can see the libraries I use for this project, and these are the pin definitions in my project. And these bitmaps I use to show my images on OLED display. So these are the bitmap codes. And you can see there is our Wi-Fi configuration. So I use this Wi-Fi connection to connect with my device, and use this server URL to connect with my device. So you must remember you don't want to use localhost for this server URL. So you can get this IP address using your command prompt, and now you can use it in there. And right, guys, these are the codes. So you can see I create this method to send my payload to server. And right here you can see my setup method, and I code these codes in my setup method. And considering about my loop method, I use these readings. I got these readings to show my temperature and my device temperature and humidity and soil moisture value in database. And that's the code, guys. So this is my C++ code, and I also already showed you my Java EE7 code. All right, guys. Now let's see how it changed live when soil moisture value changes and temperature and humidity value changes with the device. So then I can show you my uh, NetBeans IDE outputs and also my Arduino IDE serial monitor double-sided, so you can see how it updates. So let's go to see it. So as you can see, my NetBeans IDE output in left side and my serial monitor Arduino IDE serial monitor on my right side. And above the serial monitor, you can see my database. So let's now you can I am pretty sure you can see how it updates, and that's how our backend code works when we change the values of soil moisture and temperature and humidity. Next thing I'm going to do is I'm going to explain what are the future enhancement of this device. So let's catch up with that. So talking about enhancement for this device, I'm looking ahead to advise several enhancements to make the device even more user friendly and functional. So I plan to integrate Wi-Fi dongle circuit inside this circuit. So this AgroLink smart device that tea factory farmers and officers are using this device in several pruning sections. So it is I think it's the most important and essential part to implement that location mapping feature in our mobile application for AgroLink smart device. So providing it will provide even greater and inspirational insight, while the location mapping feature is still it's a conceptual phase, but I'm going to develop it as soon as possible. So I'm determined to explore and implement it in the near future. So previously presented AgroLink research project, it aims to bridge the gap between traditional farming practices and modern technology. By providing tea farmers with the accurate and accessible data, this device not only solve critical problems for farmers and tea factory officers, but also empowers them to improve productivity and sustainability. Also, this device you can also use this in your daily home gardening system to measure soil moisture threshold values and update your temperature and humidity like other mobile applications in your phone. So that's it, guys. This is my research project, and thank you for giving this opportunity to present my work. And I'm looking forward to discussing how this project and its future enhancement can contribute to technology advancement in agriculture in near future.